Okay, so today we are starting up with the topic of neural networks, and that's what we concentrate upon. I've tried to gone through the CBSE sample paper also, and whatever question, the calculation question which is there, rest are theoretical based itself. That also I've picked up here so that it's easier for you to understand that one category of question is from the numerical in this case also, which is not that difficult, but a process which we have to follow. Okay. Now talking about neural networks as such, of course, it is part of your deep learning, as we say. It's AI being the entire umbrella. We have machine learning, deep learning within that. So it mainly focuses upon the human brain, the working of the human brain. So they are trying to copy that. They are trying to work on that area, and they are saying that the way the neurons of our brains work, similarly, we'll try to have the network work for in a machine. And that kind of a setup is called as my neural network. Okay, this much we have been studying since class ninth also, that making my machine work like human brain is what is a neural network actually talking about. So a machine learning program or a model that makes decisions similar to the human brain by mimicking how the biological neurons work. They are trying to work on that. Certain things they have achieved also, or and further on they are expected to do much better in this field. Now इसका जो basic feature है, that is it is able to extract features in a given scenario without giving any input. If I'm not even giving any input, वो खुद से he is able to generate that thing, extract the feature which I need. Right. So that is basically what we are trying to work out here. That nervous system of a human brain, that is what is being picked up by the machine. They're trying to incorporate the human nervous system of our brain and apply that to the machine. Again, I'm repeating this, that the advantage being the ability to extract the features without explicit input from the user or the programmer, as we call it. So there are certain examples wherein it is taking play, because actually, they are trying to imply that, or use that, I should say, in every aspect of the AI examples. हर जगह पे they are trying to incorporate this kind of a working. For example, chatbots, we have simple chatbots also, but then there are auto replying emails that they are going to study your mail and analyze it is based on what, and then automatically generate a reply accordingly and answer. So that kind of a thing. Every chatbot, I will not say that it's a neural network example, but certain categories. So every aspect of the AI examples we have been doing, somewhere or the other, this is coming into play in small aspects. Then we have these recommendation systems. Usme, of course, machine learning be involved hai, and neural is also involved at a higher level. Google search being very, very intense. There also we see that these kind of things are taking its, what do you say, a part of the system. Okay. Now moving further, we are aware of the basic structure of the neural network, where we say that we have input layer, we have hidden layers, and we have output layer. So input layer takes the basic input values. There could be multiple input values, and then it processes it in the hidden layers. Okay. And final output is coming out in the output layer, which is like giving you a yes or a no kind of a thing, that okay, you go for this or you don't go for this. So that's a decision, a final decision, and the output is coming that yes, we do it, or no, we don't do it. Okay, the simple structure is like this, and when we have to write about it, we will write up to this much extent when we say the basic structure of a neural net. This we have actually done. Now the amount of hidden layers you would have, that will define the depth of the system, and that will define how good it is, or you would say how much more it is advanced. So if you have a single hidden layer, it will be a simpler system. If you have multiple hidden layers, it will have a more complex system. Okay, so these are hidden layers are like any number. There could be 30 layers, there could be 20 layers, there could be 10 layers, any number of layers, which we define that I need it according. तो उतना ज़्यादा intensely वो उसको review करता है, check करता है, process करता है. Right? Now, this is a kind of structure we are looking at. If you see it very carefully, we have multiple inputs, and that also we are saying that n inputs. So, एक decision लेने के लिए, let it be going out to watch a movie. That is my final decision, a yes or a no for going out to watch a movie. Now, there could be multiple factors which are playing a role in that. What kind of a movie it is? What are the previous reviews of the movie? Who all are the actors or the director or the musician? What are they? I mean, who are they and how much popular they are, or how much they come up with things as per your taste. So everything, then timing of the show, then your availability in terms of कितना टाइम जाने में लगेगा, कितना टाइम आने में लगेगा. So total number of time, which total amount of time which I have, whether I have or not that much amount of time or not. So multiple factors are there. All that becomes your input. And then for every input, the connections are being transferred to the neurons in the hidden layer. Now, each and every circle which you are saying, that is termed as a neuron. So these circles are my neurons or basic inputs which are coming at this point, and then they are again further on sending the out input to the next layers. So मतलब जो H1 वाला layer है, that is behaving as an input layer for H2. H2 वाला layer जो है, that is behaving as an input layer to H3 and forward. So everywhere these are behaving as inputs only. अब your question is कि हर जगह पे same input ले जाके वो कर क्या रहा है ना? We feel that. Why to transfer it into multiple layers? आप प्रोसेसिंग एक ही चीज करोगे या एक चीज को देखोगे. So why so many things? But it is not like that. What happens is every step पे ये जो न्यूरॉन के एरिया में there is a calculation being done. Okay. And if that calculation's output is more than the threshold value which we have set for this particular model, then only this neuron is activated and the data is further transferred to the rest of the neurons in the next layer. And you can see the connection goes to every layer, every neuron in the next layer. सबसे input जा रहा है. Of course, well, this particular neuron, as we say, is being activated. It's not कि every neuron से input जा रहा है हर जगह पे every time. Whatever the way they are calculating the thing, they are setting a threshold value. Suppose 3 is a threshold value or 6 is a threshold value. So हम कह रहे हैं कि अगर इस calculation का output 3 से ज़्यादा आएगा तभी हम कहेंगे कि ये node activate हुआ है and he will now be able to send the data further. अगर वो 3 की जगह पे if 3 is my threshold value वो 2 आया तो we will not consider this input going further. Then we'll see the rest of the things. Okay. So that is how this hidden layer actually, I mean the input to the various layers actually work. Number one. Number two, we see the hidden layers also are H1, H2 up to Hn. So there can be multiple hidden layers. Again, as I said, the lesser number will imply less complication and the more number of layers will lead to more complicated systems. And then finally, you have the output layer. Output maybe here they are showing us multiple outputs and then finally maybe we come up with one single final decision of yes or no depending upon the things which are coming out. Okay, so here the basic explanation to this structure is that each node is connected to others. Okay, and each connected connection has a weight. हम इसको next example में देखेंगे when we are going to solve a problem also that every connection here ये जो 1 2 3 4 एक इनपुट से वो अगले न्यूरॉन पे गया एक न्यूरॉन से दूसरे न्यूरॉन पे गया यहाँ पे and you have 4 connections working from this place because there are 4 nodes we are showing here. So 4 connections. अगर ये n connections है so n nodes है तो n connections बनेंगे for every node. So every connection has a weight. What does that weight mean? We are coming to that also later. So every connection has a weight जिसके के साथ हम इनपुट वैल्यू को मल्टीप्लाई करते हैं। if the output of a node exceeds a specific threshold value, वो मल्टीप्लिकेशन करने के बाद उसके अंदर हम एक बायस ऐड करते हैं, एक एरर वैल्यू चेक करते हैं, वो सब करने के बाद अगर इस पर्टिकुलर इनपुट का आंसर, if it is more than a threshold value, then only this particular node is taken as one of the important factors in decision making, and hence the data is passed on forward. अगर इसका आउटपुट वो नहीं आया जितना मुझे चाहिए, उससे कम है, then I will not take this person's input into consideration. So that is what we are trying to say here. If the output of a node exceeds a specific threshold value, the node is activated and its output is passed to the next layer of the network. Otherwise, no data is transmitted to the subsequent layer. I ate the last word, I think, but that's how it is. Okay. So that is how the system works. A basic explanation. Okay. Certain important things on the left side says that an ANN with two or more hidden layers is known as a deep neural network. So the moment the number of layers increase, I am calling it a deep neural network. Now why deep? You may take it up as the depth of the hidden layers is increasing. जितने number of layers बढ़ गया उतना उसका depth बढ़ गया, and hence the term deep. The process of training them is called deep learning. We know this term. The term deep in deep learning refers to the number of hidden layers, also called the depth of the neural network. So जितना डीप हम जाएंगे उसको लेके, जितने ज़्यादा लेयर्स होंगे वो उतना ज़्यादा कॉम्प्लिकेटेड प्रोसेसिंग को हैंडल कर सकता है, कॉम्प्लिकेटेड डिसीजन मेकिंग को हैंडल कर सकता है. If I want to keep it simple, I'll have maybe just one processing layer, as we call it, the hidden layer, सिंगल लेयर, एंड वो इनपुट लेगा और अकॉर्डिंगली चेक करके आउटपुट दे देगा तुमको. सो दैट विल बी अ वेरी सिंपलर वर्जन ऑफ द न्यूरल नेटवर्क. Now, before I move on to working on those, like a situation where we are going to calculate the, see the working of the calculation, let's first pick up the terms which we are going to use. Okay. First one is neurons. Now, what are those neurons? Those circles which you saw, those are my neurons, or nodes as we call it. They are the fundamental blocks. हर नोड पे इनपुट आ रहा है, आगे वाले से इनपुट आ रहा है. ठीक है ना. इस सारे इनपुट्स को हमें कैलकुलेट करके सम अप करते हैं आफ्टर डूइंग सम कैलकुलेशन ऑन दैट. बट दैट इज हाउ द input is coming and we apply an activation function on that to produce the output. That's the basic definition. अगर वो individually भी आपसे पूछते हैं, so that is how you're going to define it. They are the fundamental building blocks that receive the input, then they compute a weighted sum. Once you understand the example, these won't be difficult to remember. And then apply an activation function on that to produce the output. Okay. Now weights. As I say, a weighted sum. Can you see here? It's got talks about a weighted sum. A weighted sum का मतलब basically यहाँ पे ये है कि जैसे मैंने बोला था पिछले स्लाइड में, that you have associated weights with every connection. ये जो हर एक connection के साथ ये वाला जो connection आ रहा है, that line you're saying, has an associated weight. Okay. That weight is the strength of the connection. और इसको ह्यूमन ब्रेन में भी बोला जाता है synapses between the neurons. Okay. By the strength of the connection, basically I mean that suppose it's one of the input is one of the factors which decides whether I go for a movie or not. So that input says traffic on that day. Like it's a 1st of January. We all know there's huge traffic everywhere. Everybody wants to go out and celebrate. So that factor is how much affecting your decision. Okay, there are 4 factors are there. Out of that, maybe this factor is very, very important. Bhaiya, I hate traffic, so I will not go if it is a traffic prone area. Or Google is showing me a traffic congestion there. ठीक है, so वो मेरा फैक्टर सबसे इंपॉर्टेंट है. रेस्ट ऑफ द फैक्टर्स, इट्स रेनिंग, इट्स मूवी शो का टाइमिंग ऑड है, or there are no food stalls outside that. Could something, I'm just saying, 3 more factors are there. But for me, the weight for the first factor or the first input is the most important one. तो उसको जो हम weight देंगे, if out of 10 I'm associating certain weights, because these are all assumption basis पे ही हम अभी काम करेंगे, तो मैंने उसको सबसे ज्यादा वेट दिया. सपोज मैंने बोला उसका वेट है 4 इनपुट है, तो इसका वेट 5 है, इस वाले इनपुट का वेट 5 है। ठीक है। सो वो उस वेट को लेगा, न्यूरॉन का जो इनपुट आएगा, और उसके साथ उसको हम मल्टीप्लाई करेंगे। So that depends, that decides on the strength of the. Obviously, it's a multiplying factor, no? You can see I'm multiplying the weight with it. तो obviously वो नंबर जितना बड़ा होगा वो उसका अमाउंट उतना ज्यादा आएगा, उसका प्रोडक्ट जो आएगा वो उतना ज्यादा आएगा, है ना? So that will have a major effect on the output. ठीक है। सो दैट इज व्हाट दिस वेट इज एक्चुअली गोइंग टू वर्क लाइक। सो इट्स द स्ट्रेंथ ऑफ द कनेक्शन, एंड ये टर्म हम बायोलॉजी में यूज करते हैं टू वर्क व्हेन वी सी द स्ट्रक्चर ऑफ आवर ब्रेन। साइनेप्सेस आर दोस कनेक्शंस जो हर एक ऐसे ऐसे में निकलता है। ठीक है। दे कन्वे द इंपॉर्टेंस ऑफ अ फीचर इन प्रोडिक्टिंग द फाइनल आउटपुट। तो वेट जिसका ज्यादा दिया मैंने, मतलब वो बहुत फैक्टर इंपॉर्टेंट है। जिसको थोड़ा कम दिया वो मॉडरेटली इंपॉर्टेंट है। जिसको मैंने बिल्कुल ही 1 दे दिया तो वो मतलब इट डजंट मैटर टू मी एट ऑल, कि ठीक है मूवी का शो सुबह 9 बजे का हो चाहे रात को 9 बजे का हो, डजेंट मैटर टू मी। सो दैट इज अ फैक्टर विच इज, दैट इज एन इनपुट विच हैज द लीस्ट वेट इन द वेटेड सम, दैट विल हैव द लीस्ट importance, or you say least contribution. Correct. So least contribution into that sum which I'm finally calculating from those weights and the inputs, of course. Okay, so that was going to be my weight. So I need the input for my nodes. I need the weights for that calculation for every particular input. Okay, I just read out this line again. They convey the importance of a feature in predicting the final output and are adjusted during training to minimize the error. उन्हीं वेट्स को आप इधर उधर करते हो इन द repeated loop structure when we study about what are the types of neural networks. तो उन्हीं को एडजस्ट करते हुए you are trying to settle down the error which you are getting finally, minimizing the error basically. ठीक है। Now the third thing जो हम उस weighted sum पे add करेंगे या subtract करेंगे, that will be my bias. That is a constant term जो common होगा for all the weights, for all the neurons. A constant term added to the weighted sum that allows the network to shift the activation function further. Okay, horizontally, now we don't understand what an activation function is still now. So you may say that is again a factor which is being taken care in the calculation. That's called as my bias. It's a constant term और वो constant है, वो change नहीं हो रहा है, जैसे weight हर connection के लिए change हो रहा है, bias is same. अगर मैंने bias 3 लिया है तो वो हर जगह 3 है। ठीक है। That's my bias. Then comes the activation function. Now, this is the actual, you may say, this is the program, that small program, which is taking my decision, the final decision. The activation function, इसके भी बहुत categories हैं, lot of things are there. But this is the fellow who is taking the final decision that मुझे इसका जो पूरे calculation का जो output आया उसको मैंने threshold value से compare किया, and then मैंने decide किया कि ये threshold value से कम है, तो I will not consider this particular factor at all. Or I will consider it if the value is more than the threshold value. ठीक है। तो वो सिग्नल को आगे फर्दर मूव करेगा। सो एक्टिवेशन फंक्शंस आर लाइक डिसीजन मेकर्स दैट डिसाइड वेदर द न्यूरॉन शुड बी एक्टिवेटेड, कि वो सिग्नल आगे भेजे या नहीं भेजे। दे हेल्प द न्यूरल नेटवर्क लर्न एंड मेक द decision. So activation functions are meant for that. So these are the 4 things which, when we are working in a neural network, plays a very, very important role. They are the components, I may say. The neurons, the weights, which are also my synapses or my connections, the bias, and the activation function. 4 things. Okay. Now, the basic learning rule में जैसे कि हमने यहाँ पे सीखा कि neural networks is adjusting the weights, he's going to adjust the bias, and then he's going to better my system with time. Okay. उसके लिए they have given you 2 kind of setups. One is a forward propagation and the other is the back propagation. Now it is simply that आपने एक input लेके, एक set of weights, एक set of bias लेके, एक set of activation function लेके calculation किया. So you went forward in the neural network and you made the calculation, you got the result. Right? Now उसमें there are error factors also. Error भी निकल नहीं, ये तो नहीं है, this is not matching with my real situation, so ये इसमें इतना error factor है, 7%, 5%, whatever it is. Now I have to minimize that error. To minimize that error, यू टेंड टू गो बैक एंड फाइन ट्यून योर वेट्स। अब वो वेट्स को मैंने जिसको 5 दिया था उसको मैंने 4 कर दिया, जिसको 3 दिया था उसको 2 किया, बायस को चेंज किया, मैंने वो पूरा का पूरा हल्का 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 चेंज किया टू अगेन रीडू द होल थिंग, सो एज टू सी वेदर माई इट इज इम्प्रूविंग और नॉट। आई मीन रादर टू इम्प्रूव इट ओनली आई डू दैट, अदरवाइज वाई विल आई डू इट। ठीक है। सो आपने पहले तो एक राउंड में फॉरवर्ड में चलते गए और आपने वो काम किया, एंड देन यू अगेन केम बैक to adjust the weights so that the output is improved, है ना। दैट इज हाउ द मशीन इज लर्निंग ऑल्सो साइमल्टेनियसली। उसने आउटपुट फर्स्ट में कैलकुलेट करा और उसके बाद वो फिर उसको अपने सिस्टम को इम्प्रोवाइज करने के लिए बैक जाता है टू एडजस्ट द वेट्स एंड द बायस। So that is the rule of learning for a neural network. Of course, it is learning with time, right? That is definitely because if you see the if you remember that entire centric diagram, there we have AI and then we have machine learning and then we have deep learning. The deep learning is part of machine learning only, isn't it? So deep learning में तो मशीन लर्निंग हो ही रहा है। सो दैट्स द रूल ऑफ लर्निंग। कैसे वो करता है, वो पहले तो इस तरीके से लर्न करता है फॉरवर्ड जाते हुए, और उसके बाद वो एरर के बेसिस पे बहुत ज्यादा एरर आ रहा है या बहुत ज्यादा वेरिएशन है तो देन अगेन ही गोस बैक टू एडजस्ट द वेट्स एंड द बायस एंड एवरीथिंग टू इम्प्रोवाइज ऑन अ सिस्टम। दैट इज व्हाट इट इज टॉकिंग अबाउट। फॉरवर्ड प्रोपगेशन में हमने प्रोसेस अभी देखा, इनपुट्स आर मल्टीप्लाइड बाय देयर वेट्स, दीज वेटेड इनपुट्स आर एडेड अप, द बायस इज एडेड, द रिजल्ट गोज टू द एक्टिवेशन फंक्शन विच डिसाइड्स वेदर द नोड शुड फायर इट, मतलब इसको आगे लेके जाना है या नहीं लेके जाना है, and then if it fires, the output of that particular node goes to the next layer. That's the normal process we have learned. अब back propagation में क्या हो रहा है? That's the essence of neural network training. जब हम machine को train कर रहे हैं तो this is a very very important factor that I am able to come back. It is a practice of fine tuning the weights of the neural network based on the error rate. I mean अगर कुछ ऐसा possibility होता हमारे एग्जाम्स में भी कि मैंने पढ़ के एक बार एग्जाम दे दिया एंड देन आई एम asked to review my paper once checked and then you adjust. Actually, that happens. You're giving the second exam based on what you have learned from your previous exam, isn't it? जो गलतियां हुई उसको तुमने फाइन ट्यून किया, वो वाले पोर्शंस को दोबारा पढ़ा, जो चीज आपने सोचा था मैंने सही किया है वो गलत हो गया, सो यू अगेन डिड दैट थिंग। तो वही चीज हम लोग इस प्रोसेस में लाने की कोशिश कर रहे हैं, द फाइन ट्यूनिंग based on the error which happened last time. And practically also that definitely happens. So it is a practice of fine tuning the weights of a neural network based on the error rate or the loss. ये loss के भी बहुत सारे categories हैं जो are defined technically. Obtained in the previous iteration. The technical name here they call it as EPOCH, epoch. But that's basically the iteration in simple terms. Don't make it look complex. Proper tuning of the weights ensures lower error rates. आपने obviously उसको जब ट्यून फाइन ट्यून किया चेंज किया तो आई एम एक्सपेक्टिंग lesser errors, making the model more reliable by increasing its generalization and helping the network to improve its prediction over time. So this entire process of back propagation is that the machine improves. Similarly, you are giving PT1, PT2, PT3, the purpose being PT1 की जो गलतियां हैं वो PT2 में repeat ना हो, and hence you improve. Unfortunately, at times we see that the scores have gone down also, but then fine, that's also a learning experience for a child. But yes, it should be an improvement curve, not a going down curve, basically. है ना? Now let's move on to an example to understand the process. This is the main thing in this chapter. This is the diagrammatic explanation. Then we will move on to a proper live example of it. So x1, x2, x3 are my input features. हर एक के साथ मैंने एक वेट दिया। दिस द मोस्ट सिंपलेस्ट डायग्राम जो हर एक पर्टिकुलर सिंगल उसके साथ हो रहा है। वेट दिया मैंने W1, W2, W3। नाउ सबसे पहले आई एम गोइंग टू मल्टीप्लाई माय इनपुट वैल्यू विद द वेट वैल्यू, सो x1 into W1, x2 into W2, x3 into W3. So my input multiplied by weight has come. Then I'm going to add those values. Suppose this is 6 and this is 10 and this is 15, supposingly. So 6 plus 10 plus 15 comes here, summation. Then I add the bias to it. ये जो एक bias factor आ रहा है यहाँ पे, then I'm going to add that bias value to it. Finally, the result is given to the activation function कि भैया वो 6 आया. Now this activation function has been given a threshold value. that if the input is coming to you as more than 3, then you are going to consider this as a correct value or correct output, whatever, and hence you pass forward the input which is coming. But if it is less than the threshold value of 3, you will not take the input further on. So ये काम is activation function का है, which is like this: fx is equal to 1. This output of fx is 1. If sigma f, your summation w1 into 1 plus b, ये जो समेशन वैल्यू है बायस के साथ ऐड करके, अगर मोर देन 0 है, यहाँ पे 0 लिया है थ्रेशोल्ड करके, अगर मोर देन 0 है तो वो चला जाएगा और लेस देन 0 है तो नहीं जाएगा, आउटपुट फर्दर ऑन नहीं जाएगा. सिंपल एज दैट. नाउ हम इसको एक प्रैक्टिकल एग्जांपल के साथ कोरिलेट करते हैं, विच इज इंपॉर्टेंट फॉर अस टू नो. लाइक अ सिचुएशन आई सेड, imagine you're standing on the shore contemplating whether to go for surfing or not. You glance out at the ocean, assessing the conditions. अब ये आपके फैक्टर्स हो गए ना. आर द वेव्स बिग एंड इनवाइटिंग? नंबर 1. इज द लाइनअप क्राउडेड विद फेलो सर्फर्स? नंबर 2. एंड परहैप्स द मोस्ट इंपॉर्टेंट फैक्टर बीइंग इज दैट, हैज देयर बीन एनी शार्क एक्टिविटी और नॉट? दैट्स द थर्ड फैक्टर. Using neural networks concept, decide whether you should go for surfing or not based on these. There's a note given here. The decision to go or not to go is our predicted outcome, and that they're saying y hat के नाम से हम उसको आउटपुट को निकालेंगे. The estimated or predicted value in a regression or other predictive model are terms as y hat, because ये मेरा predicted value है. If output is 1, then yes, you go for surfing. Otherwise, you do not. Okay. Let's move on to the process. Now, 3 inputs. Are the waves good? You are taking yes as 1 and no as 0. Okay. Is the lineup empty? You are taking yes as 1 and no as 0. Has there been a recent shark activity? You are taking yes as 0 and no as 1. क्योंकि no हुआ है वहां पे, अभी नहीं हुआ recently shark activity, so my 1 goes to no. And yes is 0. Here as yes is 1 because lineup empty है और waves भी good है. They are not very much bouncing and all that. Maybe. Or big waves they are taking as good waves. Okay. So now giving us the following inputs, हमने पहला x1 को लिया 1 because the waves are good or pumping, huge waves are there. x2 crowds are out, so crowds are not there. So that is why we take it a 0. And the third one, recent shark activity has not been there. So I take 1 because मैंने no को यहाँ पे 1 लिया. So recent shark activity has not been there. ये 3 मेरे हो गए inputs. Okay. Now we need to assign some weights to determine the importance. Now again, these are all based on assumption. In the question paper, you'll be given these values because it could be 2, 1, 5 also like that, but those values will be given to you. अब यहाँ पे like out of 10, they have kind of decided कि सबसे ज्यादा weight उसको दिया जाएगा जिसकी सबसे ज्यादा मेरी importance है डिसीजन में. So here 5 has been given to the first weight because large swells do not come often. तो ये मेरा डिसाइडिंग फैक्टर सबसे मेजर है. दैट इज व्हाई आई हैव गिवन 5 as the weight to W1, and the second one, which is my crowds wala, is 2. It is not, I'm least bothered about it because I'm a Delhiite, so मुझे भीड़ की आदत है, so it doesn't matter much to me. And the third one is of course little less important than the waves, but it is important, so I've given it a 4. The sharks one. ठीक है. So depending upon your importance, you set up the weights. Then this is the tabular structure they are representing. ये input है और ये weights है. ठीक है, मिल गया. So, अब हमने क्या प्रोसेस सीखा है? इनपुट इंटू वेट. सो 1 into 5, 0 into 2, 1 into 4. ये करेंगे, फिर उसको ऐड कर लेंगे. दैट्स व्हाट वी डू हियर. 1 into 5, 0 into 2, 1 into 4. ये मैंने सम अप कर लिया, द वेटेड सम एज वी कॉल इट. And there we are saying that the bias value is taken as -3. Again, it's an assumption. Threshold value 3 लिया है, which is converting as my bias value as -3. So that is the bias being calculated, and then this final calculation comes out to be 6. Okay, so my y hat value is 6. The y hat value, if the y hat value is more than threshold, which is my 3, then the output is 1. Otherwise, if it is less than the threshold value, then the output is 0. Since 6 is greater than 3, because I've said my machine has been given the threshold value of 3. Since it is greater than 3, that output of this whole function, the activation function, is 1. So the decision is that you will go for surfing. If we adjust the weights of the threshold, we can achieve different outcome from the model. So ये threshold भी obviously हम ही decide करके दे रहे हैं उसको, या machine उसको calculate कर रहा है. So as per this assumption of threshold value of 3, I go for surfing. If I change the threshold value, obviously my output will change. Okay. Now, as per the CBSE sample paper, this is a kind of question they have given. Consider the following perceptron. अब ऐसे systems को perceptron बोला जाता है जहाँ पे you have lesser layers to work with. The simplest of all neural networks are my perceptrons. Now, the following perceptron that predicts the academic performance of a student with inputs, weights, and a bias of -2. So, you'll be given these values. Calculate the output of the predicted outcome y hat for the given scenario. इसमें आपको y hat तक कैलकुलेट करना है. You don't have to really say कि इसका threshold के साथ कंपेयर करके क्या होगा. So they have given you study hours, distractions, and sleep quality, which are my inputs, and the weights. The study hours definitely has the maximum importance. So that has been given the weight as 6, what I can see here, but that's part of the question. So you'll be given that. The TV games or distractions hold on to 3 as per the question, and the sleep quality is 2. Okay. So what is my process? 1 into 6 plus 0 into 3 plus 1 into 2. कर लिया मैंने. 6 into 1, 3 into 0 or 2 into 1, whichever way you take it. When weight into input किया, I was saying it as input into weight. Because input पहले आ रहा है, weight बाद में जा रहा है. करके then bias there is given as -2. So -2. So 6 plus 0 plus 2 minus 2, which will be 6 again. So my y hat value is 6. This is a 2-marker question given in the sample paper, and we expect these kind of questions to come in the exam. So they are basically trying to give you a simple understanding of a perceptron, that how the neural network is working on these factors, which is a neuron, and then they're taking the weights, and then they're taking the bias, and how they're calculating, and the activation function is working to finally give you the output. But यहाँ पे y hat तक उन्होंने बोला हमें calculate करने के लिए. So we have been given this particular setup to get the answer. Right? So this kind of a question is definitely expected in the paper, which we should be able to solve. 2 more things are there. Like types of neural networks. These are the names now. So neural networks के भी types हैं. Okay? Perceptron, single layer of input connected to the output. So not much of calculation being done. Like they have given an application where we talk about binary classification tasks, spam or no spam detections. That's my standard neural network. Then comes the feed forward neural network. Data flows in one direction only. Has an input, one or more hidden layers, and definitely one output layer. तो feed forward is हमने जो back propagation की बात करी है, शायद वो इस चीज में नहीं है. ठीक है. So here they are giving you some examples: image recognition and NLP, along with the regression जो भी बिल्कुल initially task में किया था. Then is CNN. CNN, if you remember, we've done it in the vision, जो कि feature extraction में use होता है. ठीक है. That's also a kind of neural network. Then we talk about the RNN, the recurrent neural network. ठीक है. recurrent neural network भी repeatedly loops में चलता जाता है, persistently उस चीज को process करता है, and these are being used for language modeling mainly, because I believe उसमें बहुत ज़्यादा importance है language को reform करने में, I mean improvise करने में. So that is why they are using the recurrent neural network here. And GAN we have studied in the previous chapter only, where we have done the generative AI. कि this is also a category of neural network जहाँ पे हम लोग realistic images और videos पे काम करते हैं. The recording will stop in any time. The last aspect of this is the